Hello everyone, I'm Kamal Noori and here is Remote Sense Geosciences channel. I'm assistant professor in Shiraz Azad University and I want to talk about electromagnetic waves. Please follow this session. Syllabus of this session. Number 1. What's electromagnetic waves? 2. The source of electromagnetic waves. Number 3. Characteristic of electromagnetic waves. 4. Classification of electromagnetic waves. Number 5. What's black body? Number 1. What's electromagnetic waves? Electromagnetic waves are the result of the interference of two types of waves, electric and magnetic. Important note: these two types of waves must have the same frequency. Number 2. The source of electromagnetic waves. Electromagnetic radiation can be produced by the sun or other resources. Other resources such as satellite or satellite data. Number 3. Characteristic of electromagnetic waves. Electric and magnetic field are two important parts of electromagnetic waves or EM waves. And wavelengths. Wavelengths is the distance between two crests or troughs. Note: the SI unit of wavelengths is meters, usually denoted as M. Characteristic of electromagnetic waves. Other note: frequency is the number of vibration per unit of time. Hertz is the SI unit of frequency, Hz. The relationship between wavelengths and frequency is inverse. For example, this slide is showing increasing wavelengths opposite of increasing energy or increasing frequency. From left to right, wavelengths will increase, but from left to right, frequency is decrease or energy is decrease. Number 4. Classification of electromagnetic waves. This table is showing the part of electromagnetic waves. Part ultraviolet, part 2 visible region و infrared IR. Wavelengths and frequency are two parameters of electromagnetic waves. For example, in visible region, blue wavelength is 0.4 to 0.5 micrometers, or green 0.5 to zero point 0.6 micrometers. And infrared vision include near infrared, short wave infrared, intermediate infrared, thermal infrared, and far infrared. Types of infrared waves based on wavelengths. NIR or near infrared, SWIR or short wave infrared, MWIR or mid wave infrared, and LWIR or TIR or thermal infrared. NIR is located between 0.5575 to 1 micrometers. SWIR is located between 1 to 2.5 micrometers. And MWIR include IR between 3 to 0.0 micrometers, TIR 8 to 20 micrometers. Comparing the range of electromagnetic waves with Lancet 7 bonds. Top is number of bond in Lancet 7 and down number of bond and wavelengths and spectral region. For example, B1 wavelengths between 0.45 to 0.52 and spectral region is blue, and B8 wavelengths 0.52 to 0.9, spectral region green to NIR. Electromagnetic spectrum in active and passive sensor. The part of down is passive sensor and top active sensor. Passive sensor include UV or ultraviolet region and visible to NIR, near infrared, and TIR or thermal infrared, and microwave, and part top active sensor include visible region to radar part, for example KA, KU, C, K and X part of radar region. This slide is showing relationship between velocity or speed and wavelengths frequency in electromagnetic waves. Based this formula, speed is equal to product of frequency times wavelengths. Speed or velocity. And this slide is showing relationship between energy and wavelengths and frequency in electromagnetic waves. Energy is equal to the product of H. H means Planck's constant times the frequency, or it is equal to product of h, length constant, times the speed divided by the wavelengths. E means energy, h, length constant, c, velocity, lambda, wavelengths, and f means frequency. Number 5. What's black body? This is a black body. But what's black body? Black body is an idealized physical body that absorbs all incident electromagnetic radiation, regardless of frequency or angle of incidence. This slide is showing black body radiation at different temperature. Black body can emit different wavelengths at different temperature. For example, in 3000 degree of Kelvin or 4000 degree of Kelvin or 5000 degree of Kelvin or 6000 degree of Kelvin. This slide is very important. The Earth's surface acts like a black body and reflects back the absorbed waves. These reflected waves are received and recorded by satellite or by sensor. Therefore, black body laws are very important in remote sensing. In fact, water, soil, vegetable, rocks, and in generally Earth's surface. In fact, as such as black body and in remote sensing, we can receive and record many different electromagnetic waves of lectans of Earth's surface. Nice picture and nice sentence for Dale Carnegie. Knowledge isn't power until it is applied. Thanks your attention.